Hey everyone! Blender's node system is amazing, and I love it. Nodes can be confusing. There's a lot of them, and they can do pretty much anything. I wanted to show how to make this cool adjustable pixelation node group, and hopefully show a bit about how nodes work along the way. So let's do that! Delete the default cube. Select the camera, and open up the side menu with N. Zero out the camera's transforms, except for the Z location. Hit numpad 0 to enter the active camera view. We're going to import an image to be our object. So under Preferences, select the Add-ons tab, type Import into the search field, and make sure that Import Images as Planes is enabled. Now under the File menu, go down into Import and you should see Images as Planes as an option. Select and open up whatever image you want to use. I found a 1920 by 1080 screenshot from a video game. Anything will work, and you can change it anytime. Now switch into Render View. In the Render Properties tab, under Color Management, change the View Transform from Filmic to Standard, and switch the render engine to Eevee if you aren't already using it. You can select the camera by clicking this camera border. Under the Object Data Properties tab, change the camera to Orthographic, and adjust the scale until the image fills most of your render area, which for me happens to be about 1.8. Switch the bottom area to the Shader Editor, and select your image plane. Here's the default Import Images node setup. We don't need the alpha channel, so disconnect this. And we don't want the scene lighting to affect our image at all, so select the principled shader node and hit Shift S, choose an emission shader. Let's switch into Material View to increase the reload speed. Back in the Preferences, under Add-ons, make sure Node Wrangler is enabled. Node Wrangler adds a series of node-related keybinds that will make working with materials easier. With the Image Texture node selected, hit Ctrl-T. We need some more room, so move these new nodes off to the side. Hit Shift-A, under Converter, add a separate XYZ node. Here's a brief and hopefully only moderately confusing explanation on how nodes work and how it applies to our pixelation node group. A lot of nodes have sliders on them that go from 0 to 1. These values, called floats, function sort of like switches, determining if something is on or off or anything in between. Not only can you use numbers in these fields, but also images. Black represents 0, white represents 1, every shade of gray in between is represented by the value from its HSV. And then there's other sliders that go from negative to positive infinity. You can use images for these sliders too, but usually have to use math since images only carry values from 0 to 1. When you first start getting into using nodes, these vector sockets are all over and it's scary. But a vector socket is just a socket that carries with it 3 values, usually location or color data. A texture coordinate node determines where the 3 values are coming from. These vectors can be separated into their 3 values using a separate node, and 3 values can be turned into a vector with a combine node. With this knowledge, we can do what essentially feels like magic within the Blender node system. It's slightly confusing at first, but XYZ coordinates are essentially the same as RGB color. Even look at the axis icon. If you switch from HSV over to RGB, you can see the value from the HSV is the amount of every RGB input. Since a coordinate is a color and a color is a vector, then a single value is technically a vector as well. A single axis at a time is a black to white gradient. But if you include a value for the other axes, there's enough data to represent the coordinates as a color. You can connect the outputs and inputs in all sorts of crazy ways to get different results. And Blender uses these colors as coordinates to figure out what part of the texture image to display where. Our base image is acting as a palette, and these gradient colors represent the coordinates on that base image. If we connect up our x coordinate to the x and y, we see this black to yellow gradient, which has matching x and y coordinates at every point. As an example, I swapped 2 sections of the x-axis gradient to show the effect it'll have on the final image. Pretty cool, right? Alright, back to building our pixelation node group. We're gonna need even more room. Shift-A, add a combine XYZ node here. Add a math node, switch it to round. Blender's round function only rounds to the nearest integer, but we can get around that with some math. Add a math node, switch it to multiply. With it selected, hit Shift-D to duplicate it. Switch the new node to divide, and drop them onto our node pipeline. Switch the multiply's bottom input to 10. And the divide to 10 as well. Now we're rounding to the nearest 10th, which is cool, but the first and last column are half the size, which isn't quite right. From 0 to 0.05 gets rounded to 0, from 0.05 to 0.15 gets rounded to 0.1, and so on. We want to round each tenth of the image to the center value of that column, so we get one solid color sampled from the center of that column. So between 0 to 0.1 rounded to 0.05, 0.1 to 0.2 to 0.15, etc. Luckily, this is something we can do with a little bit more math. Switch the round function to floor, which gives us the lowest value for each section. Select and duplicate this node, switch it to ceiling, which is the upper value of each section. Connect like so. Now we want to average these two values to get the middle. Move these nodes over a bit and duplicate the divide node twice. Switch the first one to add. Connect the ceiling node to the bottom input and switch one of the divide nodes to 2. When using Eevee, it's sometimes better to switch the texture from linear to closest. This is pretty cool, but we want to be able to easily adjust how many times we slice up our image. So Shift A, add a value node. Connect to the multiply and divide math nodes that are using the 10 value. Change this value node to 10, and now if you scrub through the values, you'll see the resolution of our image changing. Hold Shift and right-click drag to add a reroute node. Currently, when you use a value in between an integer, you get a column at the end that has a middle point outside of our image, so it appears black. To fix this, duplicate any math node, switch it to the round function, and drop it here. Now it'll round our input value to a whole number before sending it through our node system. Get all these math nodes a little closer together and box select them. Hit Ctrl G to turn them into a node group. Hit Tab to exit this node group. Alright, set the value back to 10. And let's get the y-axis involved now. Select this node group and duplicate it. Connect up the y-axis like this, and connect the value node to its bottom field. Add a reroute node here. Now as you scrub through the values, the picture changes resolution. Currently the pixels are the shape of our image plane, but I want them to be close to perfect squares or something like that, I don't know. Shift A, add a math node. Drop it between the reroute and the y-axis node group. In the bottom field, enter the ratio between your image width and height, and switch the math node to divide. Now our material will attempt to fill the image with as close to squares as possible. If you want perfect squares, get rid of the round node and the node groups. If you don't know your image ratio, duplicate the divide node and add your image width and height. Connect to the bottom value of the other divide node. Duplicate this value node, enter the width and height into here as well. Connect to the divide node. Box select all these nodes, and hit Ctrl G to create a group. Tab out. Select and delete these 3 value nodes. This top value is now our y-axis pixel count, which I get way more enjoyment out of messing around with than I should. We can tidy up our node groups a bit. Select and tab in. Select this subgroup and tab into it. You can open and close this side menu with N. Here you can name the overall node group, and under the group tab, you can name the inputs and outputs. I like to add way too many reroute nodes and make everything look kinda like circuit boards. When you're finished, hit Tab to exit the group. It's important to note, when you duplicate a node group, it's an instance version of the original, so when you change one, you change both. Let's clean up how this group looks and name the values. Select any node that isn't a group and hit Tab to exit. And there we have it. You can adjust the pixel resolution and change the pixel width and height values. And what is it that I see here? 3 value fields that you could potentially use images, gradients, or math on to make them even more interesting. Well, that was fun. I hope you enjoyed, and maybe learned a thing or two. We're going to make an RGB filter that works in tandem with this pixelation node group. That is pretty neat as well, so keep an eye out for that. Thank you for watching. Leave us a like and subscribe if you haven't already. If you'd like to help our channel grow, consider sharing the video. You'd be doing us a huge favor. Thanks again. Stay safe. I love you all. Goodbye.